All right, let's get started on part 2. Right, so I have the project instructions pulled up here. And again, everything you need is right in here. But let's go ahead. We'll read anyways. Some functions are best described and represented using polar coordinate systems, which we've talked about in class, instead of the Cartesian coordinate system, right? So r and theta instead of x and y. Polar curves are defined by the variable r representing the radius, that's what I just said, and theta, the Greek letter theta, representing the angle traversed counterclockwise from the positive x-axis. Many geometric shapes are best expressed in polar coordinates rather than Cartesian, like circles, ellipses, sectors, and spirals. Furthermore, polar plots can create some incredibly symmetric symmetries in curves like roses, cardioids, limicones, and conchoids, and cissoids. We can use the command EasyPolar in MATLAB to plot curves for the functions defined in polar coordinates. First, we define the theta with sims and define the function r is equal to f of theta and apply the EasyPolar command. So there's an example. Part 2 exercises, recall, we have this already listed. So we're looking at, this would be considered 2. It looks like there's only one part. So let's see. Consider the 2 functions defined in polar coordinates below. Plot these functions using the procedures outlined above. Use the figure command to ensure they plot simultaneously, but on a different set of axes. And so just so you know, it's still 2 different figures. I mean, it seems a little confusing there. It wants a figure 3 and a figure 4. It does not want them on the same graph. I understand that could be a little confusing. Okay, so let's go ahead. We'll jump right into it. We'll go back to our MATLAB file that we already have. Again, I did this first part 1b. It was up to you to do 1c. I left that for you. And now I'm moving on to 2a. And again, we can use the same A, B, and C, D as above, so I don't need to redefine those. However, I am using a new symbolic variable theta now, right? So I need to define sims theta, which is exactly what the instructions said. And now if we're looking at this, we need to go in, it's going to take a second, and define this R1, we'll call both of these radius, right? R here and R here. I'm going to call the first one on the left R1, the second one R2. Right, so take a second. If you want to pause the video, type in your R1 and your R2. They're going to be similar. I mean, similar. They'll be the same as mine, right? Because I'm going to leave them abstractly using the A, B, and C. So let's go ahead. R is going to be equal to, or R1 is equal to R. Oh, nope, sorry. R1 is going to be equal to A plus 1 times, now we have the exponent, so exp sine of theta. So make sure you get those parentheses right. Let's make sure I have them right here. So sine of theta, 1 parenthesis with theta, 1 parenthesis with the sine. And I think we still want to be up here, minus 2 times cosine of 4 times theta. 1 parenthesis, 2 parenthesis, perfect. And I put the semicolon. So there's R1. And so once we have R1, we can immediately go put this on a figure 3. So we'll say figure 3, easy polar, R1. Boom, that one is done. So control save. Once we've saved it, right, well, what should we do? We should go ahead and run it. And so maybe I might have to leave the second one for you. I didn't realize this is the only thing here, right? And it looks like a butterfly, right, which is what figure 3 should look like. So just so you know, if you're watching this video, hopefully you are, figure 2 is supposed to kind of look like a tornado. Figure 3 here, we have a butterfly. Figure 4 should look like a Pac-Man, right? So just so you guys know, I'm just going to put the comment here. Let's put butterfly. Right, so I'm not going to do figure 4. This is another short video, but figure 4 should look like a Pac-Man. So, and I'll give you the hint, right? What should you do? You should define R2 to be equal to something. Then you should probably put figure 4 here, right? So And then you should just do, right, easy polar of R2. Now, so the only real part that you have to go do, I've kind of done the whole thing, is just go look at your R2 that's given to you in the instructions. So right here, and just go type it in. Now, I will admit this does look ugly, right? There's some absolute value signs in there. So just be careful. And there's a lot of parentheses, but it should look like a Pac-Man, just so you know. Okay, so with that, we are done with the second part, right? We have the third part. Maybe I'll post the third part today. I should be able to get to it, but at least get to these first two parts. This should help, right? I'm just leaving you with one part here, 1C, and just essentially one line of code that you just have to make sure you have the parentheses right, and it should come out to look like a Pac-Man. All right, so I will see you in the next video.